Hello everyone. What I want to do in this video is I want to do a recap of your lab activity with the molecules. So in that activity, one of the key points that we were focusing on is molecules and the way that they're held together and the way that they interact with each other. So water tends to be a bent molecule like you see here, and water is H2O. It's made up of two hydrogen atoms, which we see here at the bottom, and we also have the oxygen atom in there. And the oxygen tends to be very strong as far as its pull or its attraction for electrons. So any electrons that are held here in this covalent bond, they get pulled towards the oxygen. So since they're being pulled towards the oxygen and away from the weak little hydrogens here, we call this a polar covalent bond. And polar covalent bonds result in an area that's a little negative, which would be the area that's getting the majority of the electrons pulled towards it. And then we have the positive areas. So we've got a water molecule that happens to have a negative side and positive ends to it. Well, opposites attract each other, opposite charges. So if we have a couple water molecules, we have positive and we have negative, and those are going to want to stick together, kind of like magnets would want to stick together. And this attraction for each other, which you see right here between my water molecules, that's going to be called a hydrogen bond. Hydrogen bonds are very important in nature and in biology because water molecules are always interacting with each other. And the way that they interact with each other is going to be with these hydrogen bonds that they form with each other. Well, water has these sides that have charges, and those charges don't just want to interact with other water molecules because, again, opposite charges attract each other. So if there happened to be something else, say something like a sodium atom, that sodium atom might have a positive charge, and water happens to have a side that is negative. So positive and negative, they would be attracted to each other. So in that way, the water molecules would come over here and they would actually surround the sodium atom. And if they're able to do that, then the sodium gets dissolved in water. So water can dissolve things that have a positive charge. You also had in your activity, you had some chlorine, and the chlorine had a negative charge. Well, things that are negative would be attractive to things that are positive, and the water has a positive end too. So the water is going to want to surround the chlorine because it's negative like this, using this positive side. And if we can get a nice coverage of the water molecules around the negative chlorine, then the chlorine gets dissolved in water. So water can dissolve things that have charges, and this doesn't just have to be tiny little things like atoms. It can be larger structures like a sucrose molecule or a sugar molecule. So you dissolve some water, dissolve some sugar in water, and yes, it dissolved in water. Well, the reason for that is that the sugar molecule is made up of a lot of polar covalent bonds like the water molecule, and that means there's lots of areas that are a little bit negative and areas that are a little bit positive. So if this happened to be my sugar molecule, then the water molecules can kind of coat the surface and interact with it, always putting the areas of opposite charge next to the areas that have the positive charge on the sucrose. So if this area right here happened to be a little bit negative, well, the water would put its hydrogen ends next to it. If this area happened to be a little positive, then the water would put its negative ends next to it. But overall, what's going to happen is that we have a molecule that has charges, and the water is going to interact by putting opposite charges next to it. So water likes to dissolve things that either have a charge or they have little areas of charge. Now, if you have something that doesn't have a charge, then water really would rather just hang out with other water because the water molecules have charges that other water molecules can interact with by hydrogen bonds. In the case of oil, oil is a substance that is very neutral. It's neutral because it does not have polar covalent bonds. It has non-polar covalent bonds. So there's no charges on the surface of that molecule for the water to interact with. And in the end, what that means is that the water molecules just all hang out together and make hydrogen bonds with each other. And the oil molecules, which are non-polar, are going to hang out together. So when we talk about solubility, like mixes. Things with charges like to mix with things with charges. Things that do not have charges and things that are neutral, they will tend to hang out with substances that are also neutral. So I hope that helps you understand exactly what you are modeling and looking at in the lab. Just to tie into the grading of the labs, everyone, for the most part, did a great job with that. With those labs, make sure that you always capture all of the pictures that are specified, and you have those included, and then also the labeling is really important. So when in doubt, add some more labels, point out the key aspects that we're looking for in that lab, and you should be able to score really nice grades on these.